Hello, my name is Philip Tomanak, and I am a researcher in the Faculty of Engineering. Today, I want to show you how we can use computers to reveal surprising patterns in mathematics, with a focus on how researchers can use these computers to carry out large numbers of calculations with familiar examples. If you stick around all the way to the end, I'll put everything together in an interesting demonstration. You are probably either learning or already familiar with images like this. Today, I want to talk about the multiplication tables and how we can visualize relationships in the simple process of multiplication to reveal surprising patterns hidden in numbers. We'll see that hidden away inside this multiplication table are patterns that look like this. To do this, I want to share with you one of the most important tools available to scientists, engineers, and mathematicians: computer programming. I'm an engineer, and in my research here at the University of Wisconsin-Madison, I use a programming language called Julia. I use Julia to carry out complex mathematical calculations that take me too long to do by hand. That's one reason we use code. You can learn to solve a lot of different problems by using a computer, because as complex as any of this may look, at the end of the day, all the computer does is carry out a set of instructions. For example, I might write code to load some data, carry out some calculations using this data, and then graph the results so I can share my work with others. Ultimately, I'm going to use Julia to do a bunch of multiplication calculations and then draw a picture. You can do this too with a pencil and paper, but Julia can do it very quickly. First, I will show you how we derive an interesting pattern called a cardioid, meaning hard-shaped, from your multiplication table. First, we'll need a circle, like this one on the right. We want to draw lines on this circle, so we need to number it. We'll number the circle counterclockwise from 0 to 100, so we can count around the circle like this. Like a clock, we can keep counting past 100 by continuing around the circle multiple times. So 200 is 2 times around the circle. Next, we'll pick a row from the table. In order to see our cardioid, we will pick the corresponding row to the number 2. Finally, for each multiple of 2, we will draw a line on our circle, starting from the number we want to multiply to the number in the table, like so. From 1 to 2, 2 to 4, 4 to 6, and so on, 3 to 6, pardon me, and so on, all the way up from 100 to 200. If we draw all of these lines, we'll see something like this. Here, I've used Julia to animate the process. You can see the pattern emerge one line at a time. Who would have guessed such a pattern was hidden in the multiples of 2? But what about the other rows of the multiplication table? Here's what happens if we choose 3. Now we seem to have 2 cardioids. And here are the 4s. There is definitely something interesting happening as we work our way down the table. So here's another question. What about the values between 1 and 2 or 2 and 3? Let's see what happens when we choose decimal values. Now we can see there's a pattern here as we move down the rows of the multiplication table. Here I've animated the circles, with each frame of the animation representing a number between 1 and 5 on the rows of the multiplication table, including the decimal values between the whole numbers. That way the animation looks smooth. With this, we are capturing the patterns in each row of the table and in the columns. What we have is an animated representation of the relationships defined by the mathematical operation of multiplication. And I think this is really neat. If you want to try this at home, you can print out this template that I've put together. All you should need is a pencil, a ruler, and a calculator. I've placed 100 intervals on this circle for you, so you can choose any multiplier you would like. For fun, why not try it with colored pencils and see what kind of patterns you can find? Before I get to my last animation, I would like to thank you for participating in the Wisconsin Energy Institute's 19th Annual Science Expeditions. I hope you have enjoyed this presentation and that you will enjoy the others. As a final thank you for watching all the way to the end, I would like to share a more complicated animation. First, I like to color these animations by their starting point on the outer circle. So any line starting here will be red, and here will be blue, and so on. I also like to use larger numbers, where the complexity of the patterns is more pronounced. I think this illustrates another advantage of using a computer to do this work, because I certainly wouldn't want to calculate multiples of 343 or 2401 to draw these by hand. In the following animation, I'll animate 4,800 multiples between the numbers 167 and 375. Without further ado, please enjoy the following animation.